Okay, today's video lesson is about Miller and Urey. This will be a short lesson. There's not much to write down, but it's important that you listen carefully, take down the notes that are on the screen, and then we will do our interactive notebooking after that so you can make sure you understand their experiment and why it's important. So write these notes down in your journal. This is all about Miller and Urey. Miller and Urey are a couple of guys who lived in the 1950s, and that's when they did their experiment. And they wanted to understand better how the universe was created, how things came about. Where did the molecules that make up living things, where did they come from in the first place? And so their experiment is all about trying to test a hypothesis of a guy named Alexander O'Parent. He developed a hypothesis in the 1920s about how he thought the Earth was in its early years when it was first formed, and how those conditions could have led to molecules like proteins and nucleic acids being formed out of the different conditions in the atmosphere. So let's write down our notes, pay close attention, and then when you are done, you're going to do your interactive notebooking. Right, so scientists have questioned how the first biomolecules came about for hundreds of years. For basically as long as humans have been around, we've been questioning and wondering where we came from. And everyone tries to answer this question, and many of us have different beliefs than what the scientists hold, and that is perfectly fine. But today we're talking about what the scientists, from a scientific point of view, how we tested, how scientists were able to test certain hypotheses about how biomolecules were first created. Stanley Miller and Harold Urey were chemists who studied Alexander O'Parent's hypothesis on the origin of biomolecules, and then they designed an experiment to test it. So let's take a look here at their experimental setup. So the experiment. Miller and Urey designed an experiment that was able to recreate Earth's early atmosphere and environment. Okay, so let me take you back to Earth's early atmosphere. Right, we called this the primordial soup. Right, so you may have heard of this word. If not, then I'm telling it you now. The primordial soup. So at this point in Earth's early atmosphere, it is thought that the Earth was extremely hot, very tumultuous. It had lots of lightning and electromagnetic activity going on, lots of volcanoes. It was very hot. There was lots of liquid. There wasn't a lot of land yet, so it was not the same Earth that we live in and are familiar with today. So it was very different. And so when they began to set up this experiment, they took all of those things into considerations about the scientists before them who had researched and hypothesized about Earth's early atmosphere. And they took all of that into consideration when creating their experiment. So to begin, they actually are going to boil water. Why are they boiling water? They're boiling water because the water on Earth at this time was, it boiled. The Earth's surface was so hot that the water naturally boiled, and so the temperature, so the water would boil and then the water vapor would rise. So in the next step, they added in hydrogen, ammonia, and methane gases, which are the gases that were thought to be present in the atmosphere at this time. So they added these in, so then as the water rose, the water vapor mixed in with these gases, these atmospheric gases. Okay. Third, the mixture was then exposed to a shock of electricity. Okay, this simulated lightning. Like I said before, this time in Earth's history, it was very tumultuous. Okay, so there was lots of lightning and electric activity going on Earth's atmosphere and on Earth. And so they added this to add energy into the experiment to simulate this lightning. And then lastly, the last step was allowing the mixture of the water vapor and the gases, after it was shocked with an electric shock, it was allowed to cool and condense and collect in the bottom. So take a moment, make sure you have this written down so that you fully have an understanding of the experiment. And we are going to go on to the next slide where we actually get to look at their experimental setup. So here is the experiment that Miller and Urey developed. As you can see here, this was our first step down here, was boiling the water. We boiled the water. From here, our second step was we added in our ammonia, the methane, and the hydrogen gases were entered in next. You can see here that the steam is traveling up through the tube, and then we have our gases coming in this direction. So then all of this mixture is going to travel around the tube over to this area, where the third step was we introduced a spark, okay, to simulate the lightning. And this spark gave the energy needed for the atoms in the gases and the water to rearrange and form different molecules. So after this point, the fourth step was that we condensed it, and then we collected our final mixture down here at the bottom. And at the bottom, Miller and Urey actually were able to recover amino acids that had formed from this experiment. And so this allowed them to, it supported their hypothesis that this method could be a way that biomolecules originated on planet Earth because of the atmosphere and the gases and just the environment on Earth at the time could have caused these amino acids to be created. And this is actually pretty huge because now, since amino acids can be created, we know that amino acids are needed to make living organisms. And so for scientists, this was a huge breakthrough. And so Miller and Urey are well recognized for designing this experiment and testing it and actually getting some good data from it. So this is the end of our video. You can make sure you have everything written down. I have an experimental setup for you to glue in your journal and number like we've numbered here in the video. So make sure you get that and get it glued in, and you should be good to go.